Welcome to our channel Derivation Nexus. Okay, today here we are going to talk about the light reflection and refraction. This is going to be our video 2 today. Okay, yesterday we have completed the video 1. So the video 1 about what is light has been completed. Today we are going to video 2, that is the lecture 2. Here we are going to talk about what do you mean by reflection and the surfaces. What are the types of surfaces? Smooth and rough. Next, the logic, how light interact with surfaces. And from this, we are going to know what is law of reflection. After that, we are going to talk little bit about what are the mirrors are there. Okay, plane mirror, spherical mirror, in that concave and convex. Okay, let's start the video now. Let's start the video now. Okay. So, first we are going to know what do you mean by reflection? Reflection. So, wherever you see this TION, that it means that you are talking about some process. Okay, it is a process. What is the process here? Here it is a process of bouncing back of light. Okay, bouncing back of light. Okay, if the light rays, whatever it may be, the light rays, if it falls, get incident on some surface at a point, okay, then it gets reflected. That is, the light ray gets bounced back. Okay, this process is called reflection. Okay, here, this process is called reflection. For this, we need light rays. We need light rays. And after that, we need a surface a surface on which the light rays gets incident on which the light rays gets incident, that is, on which the light rays falls. Okay, after falling, it gets reflected. Okay, it gets reflected. Here here we have talked about the reflection, right? In the reflection, it is a process where when light falls on surface, okay, it bounces back. It bounces back. So the light falls on surface, right? The light falls on some surface. The light falls on some surface. So we are going to know what this surface means and the types of surfaces. What is this and types of surfaces? What surface means in the sense, the scope of the meaning surfaces. Okay, that is, which and all are called as surfaces and which are not surfaces, and which we can call it as a semi surface or pure surface or no surface. Okay, next, the types of surfaces. After that, we are going to talk about bouncing back of this light. Okay, bouncing back of this light. So when it comes, why it bounces, why the light gets bounced back, after that we are going to learn how it will bounce back. Is there any law governing it? And why that law has been established? Okay, this we are going to learn now. Okay, so we have learned here now. Simple definition of reflection is nothing but when a light ray hits a surface, when a light ray gets incident on a surface, when a light ray falls on a surface, that light ray gets reflected back, or we can say that that light ray gets bounced back. This process of light bouncing back is called as reflection. Is called as reflection. It's called as reflection. Okay. So we know what is reflection. What is reflection? So it is process. Okay. This has been completed. So what is reflection has been completed. After that, let's go about the surfaces. Surfaces. Okay. Surface is nothing but which stops light. Surface is nothing but which stops light. Okay. So first of all, we learn what stops the light. So light is an electromagnetic radiation, which we have learnt in the first video. What is light, right? It is an electromagnetic radiation. That is, it has both electric and magnetic fields. Okay, it has both electric and magnetic fields, which has been accelerated. Accelerated. Why it has been accelerated? Which helped it to accelerate? That is nothing but the energy. The energy made them to accelerate. That is, this electromagnetic radiation consists of energy. It consists energy. That is, the light contains energy. Okay, the light contains energy. Okay, and you have to know something. If any source of energy comes in contact with comes in contact with an atom, okay, comes in contact with an atom, the electron will interfere. How it will interfere means either electron may absorb that energy or may not absorb the energy. May not absorb the energy. Okay. See, it is an atom. In middle there is nucleus. Okay. In nucleus there are neutrons and protons. Okay. This this attracts the electrons, making these electrons not to escape outside the atom. Okay. So if the electron needs to escape outside the atom, it should need some energy. Okay. It should need an energy greater than this proton and neutrons force. Okay. So this is called as activation energy, or we can say it as escaping energy. Okay. When these electrons gets energy which is more than the force applied by the protons and neutrons, then this electron gets escaped from the atom. Okay. You have been learning about how these electrons are arranged. Okay. This is the atom. Here there are nucleus. You have learned that there are different orbitals, right? Like this circular orbitals, right? Actually, the orbitals are not in circular shape. S orbital in sphere shape and p orbital in some other space shape and d in other shape. Okay. So due to this different shapes of orbitals, when some energy, okay, when some energy hits or passes through this atom, the electron will react to that energy. The electron tries to absorb the energy, but but will that absorb or not depends upon some things. Okay. Okay. If electron absorb or not, when it absorb, when it absorb, when it absorb means when, if the electron is in first shell. Okay. If the electron is in first shell, shell means it's not a physical thing. Okay. Let me term it as a first layer. Okay. Atom is made up of not shells or anything. Okay. Due to the force, the protons and electrons gets together through a nuclear force and forms a thing called nucleus. It is not round in shape. Okay. If there are two protons and two electrons, two protons and two neutrons, this is nothing but the nucleus. Okay. You have been learned that nucleus is round in shape. No, 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 no. It is not round in shape. No, it is not round in shape. Okay. Due to the force, if there are two protons and two neutrons, together forms nucleus. This is nothing but nucleus. Okay. After that, due to this nucleus force equivalent to these protons, if there are two protons, the opposite electron should be two. Okay. Two electrons should be, it will be revolving around this nucleus. It will be revolving around this nucleus. So that's it. There is no this circle shape or nothing. So this is nucleus. These are electrons. That's it. This is your atom. This is your atom. Okay. But actually here, when it absorbs energy, when it absorbs energy is due to the different shapes of shells. Okay. Whatever the shell you can call it as, the layers, whatever you can call it as for understanding purpose. So due to different shapes of these shells or layers, it cannot directly escape, or it cannot directly go to different layers at once. Okay. So if it, for example, if it is in first layer, okay, first layer, if it gets any light over there or some energy there, it absorbs the energy. And if it absorbs the energy, it need to go farther away, because the energy is the thing which repels it from this proton and neutron, that is from the nucleus. It repels it from the nucleus. Okay. When it gets energy, it has to move forward. It has to go to second layer, third layer, fourth layer, like that. Okay. So due to different shapes in that, it cannot go directly from first layer to third layer. Okay. From first layer to third layer, it cannot go, because, for example, see, the S orbit, the first orbit will be in this circular or sphere in shape. Second orbit will be like this. Okay. Third orbit like this. Fourth is like this. Okay. Due to this, some force doesn't allow this electron to go to some other shell directly. Okay. So this only needs to go only one step further. It only goes one step further. For example, if electron is in first shell, first layer, it only can go at once to the second one. After it gets to second one, then if it absorbs any energy there, then it can go to third one, and after to fourth one. That's it. It cannot go from first to third directly. So due to this, it can only absorb energy, because if it only can go from first to second, if it can only go from first to second, it only needs the energy which helps it go to first to second, right? If any excess energy is there, it won't absorb itself. Okay. The electron doesn't absorb it. Okay. So when it absorbs means, if any electromagnetic radiation or any energy or any light that enters an atom, That light should carry the energy. That light should carry energy equal to make electron just go one level higher. That's it. If it is less than that, if it is less than that, it doesn't absorb. If it is even more than that, then also it doesn't absorb. Then here it doesn't form any surface at all. If the electron absorbs the energy, that is, it stops the light. It stops the light for a bit. Okay. Due to this, it becomes a surface. Due to this, it becomes surface. Surface is nothing but that something stops it. Surface is nothing but that something stops the light. Okay. Which stops the light? Which stops the light actually? The light here means different wavelength lights. Different wavelength lights. Right? Some surface can stop some wavelengths, then for that wavelength it becomes surface, not for other wavelengths. Okay. For example, microwaves can pass through most of the surfaces, even your wall. Okay. Even X-rays can pass through your skin, can pass through your muscle, but cannot pass through your bone. So here for the X-rays, bone can be the surface. Bone can be the surface. But for normal light, just your skin or even your hair can be surface because this chops normal light, visible spectrum light. But for microwaves, but for microwaves, even wall is not a surface. For a microwave, even wall is not the surface. For the radio wave also, even wall is not the surface. Okay, because it can easily pass through. When it comes to microwave, it may there may be difficulty in passing, but for radio wave, it can pass through walls. No problem. Okay. So for those things which stops the light, for that light, it becomes surface, not for the other light. Okay. And a transparent medium cannot be a surface. A transparent medium cannot be a surface. A semi-transparent medium, a semi-transparent medium, that is a tinted glass. Okay. Tinted glass, it partially it partially stops light, or we can say blocks light. Okay. And it reflects. It partially stops light and partially allows. Okay. Here, of course, it becomes surface, but as a semi-surface. Okay. So these are about surfaces. Okay. After surfaces, after surfaces, we have to know different types of surfaces. What do you mean by surface has been completed? Then different types of surfaces. The surface, the surface can be smooth and can be smooth and can be rough. Two types of surfaces. When it comes to a glass or when it comes to your mirror, it is a smooth surface. Example here, example, mirror. For smooth surface, example, mirror. Here, for rough surface, example, wall. Wall is not smooth actually. Okay. Or another example is your body. Your body is also not smooth. Okay. Smooth surface and rough surface. Okay. Now we have to know, okay, different types of reflection. Okay. Before going to different types of reflection, we need to know the logic how the light interacts with the surface. Okay. In first video, we learned that light is not actually particles, or light is not rays. Okay, not straight rays. Okay, and it is not actually particle, but it behaves like particle. It is not actually rays, but your perception makes it look like rays. Here, it actually behaves. It behaves like particle, but here it is your perception. Due to your perception, it looks like rays. Okay. Actually, the light is propagated, spread as waves. Okay. See like this waves. If these waves move, if these waves move like this, move like this, move like this intersected portion, whatever you see here, this point of intersection is what we look, because we won't see these rays. No, no, not rays. We won't see these waves. We only look the intersection of these waves. The wave here, the light waves are nothing but electromagnetic radiation. It has both electric and magnetic fields. When one electric magnetic field becomes intersected to another, it is visible to our eye. Okay. While moving, we see these points moving very fast. These points moving very fast, which looks like straight line, that is light rays. Due to your visual perception, it is looking like light rays. But due to quantum mechanics is nothing but the physics related to the very tiny particles, that is the fundamental particles like electron, protons, neutrons, quarks, etc. So by studying them, the scientist has noticed that the light or whatever electron, whatever it may be, it behaves like both wave and particle. This is called wave particle duality. What? It is called wave particle duality. Due to this, it actually behaves like both wave and both particle. Okay. So here, these waves when gets intersected and gets moved, due to our visual perception, it looks like light rays. Actually, it is wave. Okay. Now we come to know the logic. I have said that electrons absorb the light. Okay. Electrons absorb the light. How about it absorb the light? That is, how much it can absorb. So, how much it can absorb, how long it can absorb, how long it can absorb. Okay, how much it can absorb? See here. This is an atom. Here we have nucleus. Okay, here there is an electron in the first shell or first level. Okay, it needs to go to second level. There are two electrons here. Here there is one electron. Okay, actually in the first level there must be two. Okay, there must be two to complete its whatever the place. Okay, the place is assigned to two electrons, so there must be minimum two electrons over there. Okay, if a light rays, or if the light gets passed here and hits this electron, it absorbs Let us assume that all conditions has been followed. That is, the light rays only carrying the energy which makes this electron to jump only to the second layer. Okay, only one step further. Okay, only one step further. If the light rays come here and it absorbs, it goes to the second one. Okay, so here already existing electron in second one doesn't move here because it hasn't absorbed any energy, right? So it will be in that energy shell only, energy level only. So here, there, for temporarily, we lost one electron in the first shell. So it becomes imbalance. It makes imbalance. Due to this imbalance, it need to correct the imbalance. So a tendency occurs that whatever the electron energy gained, right, and gone to the first second energy level tends to come back to the first energy level by releasing the energy, because due to this force difference it creates a tendency, that is, this pulls that electron again here down, such that it need to release energy, because in this shell, in this first level, with energy it cannot be here, so it needs to release the energy and come here. So here you have understood that the light which is absorbed by the electron, how much it absorbs only the energy that it gets it to the one step further, right? So in the level 1 energy shell, if there is any electron, it only absorbs the energy that carries it to the next level. That's it. Okay. And the light should also contain only that part of energy only. If it is more, it won't absorb. If it is less, also it won't absorb. Okay. How long it will absorb and be like that? Very within seconds, in by microseconds it will come back. Okay, so in within seconds and microseconds, if a light ray fall on any surface, at that point there will be an atom. In that atom there will be electron, and that electron absorbs it, and that in fraction of seconds, in microseconds, it emits it. Okay, this is what you have learned now. Okay, now see the logic begins. So here, see, this is the surface here. Okay, this is surface. Let's draw it very smooth. Okay, straight one. This is surface. Okay, this is surface, and we are having this light waves. Okay, see, first condition. First condition. This is surface, and let it be the surface. It is big electron. Okay, or atom. Okay, this is atom. I have zoomed it. Okay, in that surface I am zooming to one atom, nucleus. There are electrons. Okay, the light rays falling on electron, sorry, waves. We have to use the waves. Okay, see here, this is electron. Okay, let's zoom only to electron. Okay, this is electron. Okay, this is the electron. See here, if the light waves comes perpendicularly to the electron, see here, these three are perpendicularly coming here like this. Okay, like this comes here. Three, due to its perpendicularity, these three, okay, these three gets absorbed at once. At the same time, the first one gets absorbed, second one and third one, three will get absorbed at same time. So this electron releases these three waves at once. One, two, three. One, two, three. Three waves gets released at once. So see here, this is the light ray coming perpendicularly, and it also gets emitted like this only, perpendicularly, straight. So in this surface, if any light ray is falling like this, it will go in the same direction in opposite way. Okay. So if any light ray falls perpendicularly on a surface, that means these light rays, all the light rays or all the light waves, all come and all gets observed at same time and gets emitted at same time. So if any perpendicular light rays fall on surface, it also get reflected perpendicularly in the same direction. Okay, this is case 1. Okay, next, case 2. What if it doesn't fall perpendicularly? See, this is electron. Don't see the shape. Okay, I'm not a big artist. Okay, this is an electron. Here it is not coming perpendicularly like this. Okay, it is coming like this. See here, observe, like this. First, see here, the tendency here, first this wave gets observed here. See, due to this cross in nature, this part gets observed first because this part, this end, this end first touches the electron. Okay, so this wave gets observed first, next this wave, and next this wave. See here, this wave gets first observed, after this and after this. So if the first wave gets observed, the first wave only gets emitted first. If the second wave gets observed second, then after that the second wave only after first wave get released, and after the third wave gets released. See here, first wave, as it has first released, it forms a big wave because first it gets released like this wave, second and third are not yet came. So here, see here, so when second comes outside in the time itself, the first has spread across for more area. Okay, it came outside because it travels in the speed of light. Before the second one comes outside, the first one has grown. Okay, then second like this. Okay, after that, before the third one comes, the second one also will grow, right? So the first one also will grow, second also will grow, and third will also grow. See here, point of intersection, this one. Then after that, it grows like this, like this, like this, like this. Point of intersection like this. See here. Now, if you draw a straight line like this, it is showing that the light rays goes like this. But the light rays has came like this, right? Like this. The light rays has hit the surface and it got reflected like this. Okay. So it came like this and reflected like this. It came like this and reflected like this. This shows, why this shows here, here the angle in which it has bent here, the light rays which has for which is incidental on the surface in such an angle that it made the three different waves to get observed in three different times. So at how much time there is a time gap, in the same way the time gap in releasing also will be the same. So the angle here made will be equal to the angle made here. So here we observe that angle during the incidence, so angle of incidence will be equal to the angle of reflection. Angle of incidence is equal to angle of reflection. This is the first law of reflection. So the second law here, see here, if it is mirror, okay, if it is mirror, if any light ray passes like this and get incident here and it gets reflected like this, okay, actually in normal scenario, that is the light ray perpendicularly fall on the surface, that is all the light waves equally gets observed at the same time equally. Okay, this is the normal scenario. So that is perpendicular with the surface. This is the normal scenario. So this is called as normal. See here. This line is an imaginary line called as normal. That is without any deviation. If the light rays deviated from the normal at some angle, that is called angle of incidence. Okay, and it also gets reflected in the same angle of reflection. So angle of incidence equal to angle of reflection. Okay, this is the first law. And see the second law here. This incident ray, this incident ray and this reflected ray, this both along with the normal at this point of incidence all lie in the same plane. Okay, here the plane is nothing but not 3D plane. It is two-dimensional plane because light itself has no dimension. Okay, light itself is like a wave. It is a 2D one, two-dimension one. It doesn't has a third dimension, that is thickness or whatever it may be. Okay, so if it falls like this and gets reflected, normal is also imaginary line. Okay, this line also doesn't have any third dimension, that is its thickness is not there because it is not a stick. Okay, it is just an imaginary line. The light rays also doesn't have the third dimension, and this point dot also doesn't have a third dimension because a point is not a 3D figure like a sphere or something. Okay, it is a 2D one. Okay, dot. Okay, see here. Here, this is a single plane. Okay, this is a single plane. Here, see, this becomes another plane. This is one plane, this is two plane, second plane. Okay, here its point of incidence is here. In this reflection thing, its point of incidence is here. Its incident ray is here. Its reflected ray is here. Its normal is here like this. So here its plane is separate and its plane is separate. Okay, so incident ray, reflected ray, normal at point of incidence all lie in same plane. This is the second point. First one is angle of incidence equal to angle of reflection. Second is incident ray, reflected ray, normal at point of incidence all lie in same plane. Okay. Next, logic has been completed. Here another thing is there. Okay. We have talked about when it observes, right, and how much it observes. How much is it observes, we know that because if it is in first level, first shell, it can only go at once to the next shell, that is second shell. So the energy which is needed to go to the second shell, only that amount of energy it can observe, and the light carrying equal to that amount of energy only it can allow. Okay, next, if in an atom, if in an atom, okay, it is closely packed, that is if this is the nucleus and only two atoms here fixes, two electrons only fits right in the first shell, wait, only two electrons and two protons is nothing but helium. Okay, helium is an element which has only two electrons with two protons and completes the first shell. So it is tightly packed. Here no other electron gets a place. Okay, so this heat is full. Okay, here it is full. So even though energy here comes, there is no chance for this to get escaped because it is already full. It cannot move actually. Okay, it can't absorb energy because it is already full. There is no place to absorb energy. So in this case, the light ray even falls on this helium. This electron doesn't interfere with that light, so it let the light pass through it. Okay, if it interferes with the light, it absorbs and re-emits the light, so it doesn't let it pass through the atom or electron. Okay, this is another point I have forgot. Okay, next one is nothing but we are going to know in the smooth surface how the reflection happens, and in rough surface how reflection happens. Okay, a smooth surface like a mirror, in this, see here, if an incident ray falls on here, it reflects like this is the normal. So the angle of incidence, that is the deviated one, right, and the angle of reflection is same here. Okay, and even if it falls here also, it will be like this only. So when you see here in a regular reflection, if the incident rays are parallel to each other, the reflected rays also parallel to each other. Okay, so when it comes to a rough surface like this here, if it falls here, it reflects something like this. If it falls here, reflects something like this. If it falls here, it reflects something like this. Okay, here there is not a normal smooth reflection or regular reflection. Here we see irregular reflection, or we can say it as diffusion. Okay, if we stand before mirror, you can see your reflection in the mirror because the light rays are uniform there. It forms your image like what you look. Okay, if you are like this, it forms your image also like this because there is smooth reflection. That is, see, this light ray here comes incident and goes here. This light rays comes from here, goes here. See, the distance between this point and this is equal to the distance between this point and this. So if this part gets reflected and gets here, see here, if this part gets reflected and becomes here, the point next to this gets reflected and be exactly here only, because the parallel lines incident on a smooth surface is parallel actually. So the reflected rays also parallel. So the reflected ray also will be like this only. So this point and this point are congruent or consecutive, right? Here also in the image it will be consecutive. But in a rough reflection, if in a rough reflection, if this point is incident here and it gets reflected here, and the immediate point incident here gets reflected here, so by this your image you cannot see very smooth. Okay, it diffuses, or even this part may be reflected over some wall or something, whatever it may be, so you can't see your image like that. Okay, you only can see only the light emitted from. You can't see a clear image because it is not smooth surface. So For rough surface, diffusion, that is irregular reflection occurs. For smooth surface, regular reflection occurs. Okay, next one. Now we are going to learn about in smooth surface a part called a thing which is smooth surface called as mirror. In this mirror we have usual mirror, that is plane mirror, which you all see in your home. Okay, plane mirror. And the unusual mirrors you see in your daily life, but not a plane mirror, that is spherical mirror. Okay, plane mirror